All right, welcome to the second video we're going to do on malware analysis. This is for the Intro to Malware Reverse Engineering course, and the textbook that we are working out of is Practical Malware Analysis by Michael Sikorsky and Andrew Honig. The environment that we'll be working in, as usual, is our Windows XP virtual machine. We use a virtual machine for safety so that none of these malware samples that we are analyzing spread beyond our safe little bubble here and don't affect any computers that we might care about. The chapter that we are working in today is Chapter 3. We're going to be doing the first lab, that's Lab 3-1, and this is covering information from both Chapter 2 and Chapter 3. We're going to be first looking at some static analysis techniques, and then we are going to take a dynamic analysis. First thing that we're going to do is to take a snapshot. We do that for the menu up here. The menu up here, take snapshot. And we are going to name this Lab 3-1. And that gives us a starting point that we can go back to. Once we've run this malware, we can make it like it never even happened. But speaking of the lab, let's go ahead and start off with the first question. What are this malware's imports and strings? So we're going to start off, as we did last time, with a little bit of static analysis. And for imports and strings, we use the dependency walker. We're going to load up the 3-01 binary, look at our kernel 32, and realize that we're not seeing a whole lot of anything. So we are looking at possibly a packed, obfuscated, or encrypted malware that does not want us looking at what it's doing behind the scenes. In fact, we can go into PEID and just take a look at that file. And we can see that the signature that it's seeing here is pencrypt 3.1. And if you look that up, that is a binary encryptor. Checking the three statuses here, it's saying not packed, but I would tend to disagree with that since we're not seeing any imports. Why don't we go into PE view, see what it's got. We have a text section, we have a data section, but we are missing the R data section, and coincidentally enough, that is where the imports come through. But again, not a whole lot to see. We can look at our signature, file headers, stuff like that, but not important at this moment. Why don't we just complete our trifecta by going into strings, and I'll go ahead and transfer into that directory. And we are in the Chapter 3 directory. And we're just going to run strings on that lab 3-1. Scroll up to the top, and we can see our sections. Kernel 32 DLL. We see a WS232, so we're doing something with WinSock. Scrolling down, we have a connect and an HTTP 1.0 header. 503 and a 200, which are HTTP status codes. So we know that we are going out to the internet, probably over an HTTP or HTTPS port. Keep that in mind for when we do our dynamic analysis. We see these paths right here, which look like directories, but they are actually registry keys. So we know that we're going to be doing something in the registry. Stick a pin in that for later as well. App data, that is a folder shortcut. So we'll probably also be doing something in Windows directories. We have a Win VMX32, something called video driver, obviously a web address, that practicalmalwareanalysis.com. And that is the most interesting stuff that I see. So we're going to make a note that this is going to go over the network, probably on an HTTP or HTTPS protocol. We're going to be interacting with the registry and possibly looking at a file being created with this name here, or accessed. Let's move on to the next question, or the next couple of questions, actually, which are, what are the malware's host-based indicators, and are there any useful network-based signatures for this malware? If so, what are they? Now, we can take a stab in the dark at what those are based on the strings that we've seen when we analyzed the malware in our static analysis. However, because this is a dynamic analysis chapter, and this malware is at least partially obfuscated, let's go ahead and do a dynamic analysis and see what happens. We can look at those indicators that way. This involves running our malware, so as always, make sure that you have taken a snapshot so that you can restore your system to the state that it was in before you ran the malware. And before we run our malware, which is right here, we are going to set up our dynamic analysis environment. Because we are running a binary, of course, we want to run System Internals Process Explorer, as well as Process Monitor. And I'm going to stop event tracing for just a moment. But these two programs are your basic starting point for watching what's going on your system. As you can see here in Process Explorer, it has a list of everything that is running on the system. We can close down that system tree. And over here in Process Monitor, it's giving you individual actions that each one of these processes are taking. So that is fantastic at looking at what programs are doing on the system. What they will not give you is any kind of view into what it is doing on the network. For that, let's go ahead and start with Apathy DNS. And this is a program that will run a DNS server on your system. And any DNS calls made to this DNS server will record what the DNS request is, and then if you want it to, it will reply with a very specific IP. Now, we are going to reply with 127.0.0.1. That is a loopback address, which means that any connection to this IP will connect back to this local system that it's running on. It will run on the selected interface. We do not know which interface we are looking at, so let's go ahead and open network connections. You can see that I have 3 network connections here. The host-only connection, which connects to the host that you are running VirtualBox on, the VM NAT connection, which is your internet connection, and I have both of those unplugged for safety. And the third one here is the VM internal network connection, which does not go anywhere. If we hover over it, we can see on that tooltip that it is server adapter number 3. So we will select server adapter number 3 and start the server. One other thing that we want to make sure of is that we have assigned our IP address and set a DNS server address of 127.0.0.1, which is our loopback address. So any DNS calls will go to this Apathy DNS server. Apathy, of course, in Greek mythology is the personification of deception. Quite appropriate, and I thought it was interesting. Anyhow, moving on to more network stuff, we are going to launch 2 command prompt windows for Netcat. Netcat is a program that will open a port on your local computer, and then any information that is sent to that network port, it will either display on the screen or you can have it record that information to a file. All right, we've pathed into that Netcat directory, and we will launch the first Netcat with the arguments -L. -L is listen, -L is listen harder, which means that if the port is closed, it will reopen it. a dash lowercase p, and on this first one, we will use port 80, run that, and it is now listening. We're going to do the same on the other, but we are going to use port 443. Now, port 80 is the HTTP port, and 443 is the HTTPS port. Moving on from that, we know that it's going to use the registry, so let's go ahead and launch the regcat, or excuse me, regshot utility. This is a program that will take a snapshot of the Windows registry. The Windows registry, of course, being a sort of database that Windows and the programs that run on it use to store settings and information for when they run. We have taken our first shot, which means that we took a snapshot of all the keys and values in the registry, and it is now waiting to take a second shot and compare what's going on. So we have our process explorers, we have our DNS, we have our netcat, and we have our registry snapshot. Let's run Wireshark as well. Wireshark is a utility that will just sniff the traffic that's going over the interfaces. Going to select all 3 interfaces for capture, leave the rest of the settings as is, and start the capture. Let's go ahead and in Process Monitor, let's filter this down just a little bit to exclude the Windows processes that are generating a lot of noise in the background. And we now have a clean slate. We will clear the log and turn on capture. Now, we are ready to run the malware. Let's exclude VBox service and VBox tray, but we can see lab 3-01 did a lot and is still doing a lot. We can also see in Apathy that we have some DNS queries, which means we also have some network traffic. But let's focus right now on the process itself. So the process started. Let's make this bigger. The process started, and we are now looking at what it is doing. Immediately, we see file activity. We are creating files, file system control. We're loading DLLs, and immediately we also go into the registry. And we can come back and look at these registry values later, but as we can see, we see exactly what we were expecting from the strings. Moving over to Process Explorer, we can see that this malware is still running, so it did not shut down immediately after, which means that we can go into View, Lower Pane View, and let's look at the DLLs first. Now remember that we were looking at it in the dependency walker, and we only saw, what did we see? We only saw that one DLL, and that was suspicious to us. And we were right to be suspicious because look at all of the DLLs that it's actually running. We have Advanced API, we have a DNS API, so we're making DNS calls. GDI, which is graphics display stuff, that's interesting. Would not expect malware to be interacting with the display like that. VC runtime, Ole, user32, we have our WinSock helper, and WinSock TCP IP DLLs, so we will definitely be seeing network traffic from this, but here are all of the DLLs that it pulled when it started running. We're going to go back into View, change our lower pane view to Handles, and we can see files that it's interacting with. That's a file folder. We have directories. We have registry keys. It created a mutex, which is a mutually exclusive key that will only allow one copy of that program to run at a time. A lot of malware will run multiple copies of itself or try multiple different ways to run itself. So this mutex makes it so that it only runs one copy of the malware at a time. We have threads, that's the executable that's running, and a little bit more information here. So we're getting a better idea as we go through of what the malware is doing, and has done. Moving out of the Process Explorer, let's take a look at that DNS. So we are making multiple calls to the practical malware analysis. This is going to call home either for command and control functions or to download more components of itself as a dropper. As expected, we see some traffic over here on the 443 port, but we're not going to get anything out of that. And on the port 80, we are not seeing any HTTP traffic, no clear text traffic. So the practicalmalwareanalysis.com will be our network signature. Let's see if we can figure out the host-based signature. Peeking over here in Wireshark just to see if we have anything. We do not. Let's take a second shot of our registry and see what the changes were. Okay. Now we can compare. We have values, we have registry values that have been deleted. We have registry values that have been added. The most interesting that I see right off the bat is this current version run. This is a registry key that you can use to run a program every time that Windows starts. A very common thing for malware to do is to launch every time the machine is restarted. But here we have all of the registry changes. Let's see if we can go back to Process Monitor, and find some registry create keys. Okay, we have this reg set value here, so let's see if we can include just reg set values. We are going to include just lab.exe. We have our current version run video driver. Let's jump to that. So video driver. Here is C Windows System 32 and that vmx32to64.exe that we saw inside of the strings. So let's take a peek at that and see what that looks like. All right, here it is in the System32 directory. Why don't we pull that up in PEID? We'll do PEID. So that was C Windows System32. And VMX32 to 64. So this looks like the exact exe, or at the very least, it is encrypted with the same utility. So it looks like the malware has copied itself to the Windows System 32 directory and running itself on startup from there. So this exe would be our host-based indicator, and our network-based indicator would be that traffic to practicalmalwareanalysis.com over the port 443. All right, that wraps it up. That was a very interesting look at some malware using the dynamic analysis techniques. We got to see some file system activity, we got to see some registry activity, and some network activity. So a lot more information than we could get just from static techniques. I'm going to go ahead and reset this VM back to its snapshot state so we can start all over again, and I will see you on the next one.